Hello students, welcome to part 2 of the topic indices. Indices comes under the chapter 5 of Algebra 2. In the part 1 of the video for indices, I explained to you of the two laws of indices. The first law, the multiplication law of indices, and the second law, the division law of indices. Now in the second part of the video of indices, I am going to explain to you the remaining laws of indices. Now again I will speak to you about the third law of indices. The third law of indices states that if a term with a power is itself raised to a power, then the powers are to be multiplied together. That is, 7 to the power of 2 the whole to the power of 5 gives us 7 to the power of 10. How do you get the power 10? That is, you just multiply the power 2 and 5. That is, 2 multiplied by 5 gives you 10. As per the rule, a to the power of m, the whole to the power of n gives you a to the power of m multiplied by n. The second example I have given to you is 3 to the power of 5, the whole to the power of 3. That means 3 to the power of 5 is to be multiplied 3 times. 3 to the power of 5 multiplied by 3 to the power of 5 multiplied by 3 to the power of 5 gives you 3 to the power of 15. That is, you have to multiply the power 5 multiplied by 3 which gives us 15. Now this law is similar to the first law of multiplication I taught you in the first part of the video. According to the first law of multiplication, I told you if the base are the same, you can just add the power. So likewise in this case, you can do the same thing. The base are the same, so add the power. 5 plus 5 plus 5 gives you 15. But still then, why don't you use the same law of multiplication? Here in this case with brackets, it's better to use the brackets rule, since when the powers are of higher value, the law of multiplication will be difficult to apply. So in that case, you have to apply the rule a to the power of m, the whole to the power of n. Likewise, 3 to the power of 5, the whole to the power of 3 gives you 15, since 5 multiplied by 3 is 15. Here I have given you an example for the previous rule. That is, the example stated I have given here is 2x cubed the whole to the power of 2. Now, for this rule of the brackets rule, what you have to do is multiply the powers. Here, 2 is also to the power of 2. That means 2 squared is going to be 4. And x to the power of 3, the whole to the power of 2 gives us x to the power of 6. That is, you just multiply the given power 3 multiplied by 2, which gives us 6. So your final answer is going to be 4x to the power of 6. Now, in the second example, it is 7c cubed the whole to the power of 2. Now, that represents 7c cubed multiplied by 7c cubed. That is 7c cubed twice. So, 7 squared is 49 and c to the power of 3, the whole to the power of 2 gives us c to the power of 6. That is 3 multiplied by 2 gives us 6. This is solved as per the rule a to the power of m, the whole to the power of n, where m and n are multiplied, m multiplied by n. Here in our given example, m is 3 and n is 2. So 3 into 2 is 6. Now, I'll speak to you about the fourth law of the negative indices. Negative power can be written as a fraction. That is, 2 to the power of negative 3 gives you 1 over 8. Since 2 cubed is 8 and the power is negative, it takes a fraction form. Now you know 2 to the power of 4 is 16. Now what about 2 to the power of negative 4? That turns to be a fraction. That is, 2 to the power of negative 4 turns out to be 1 over 16. That is, this is as per the law of indices, fourth law of indices of the negative indices law. That is, a to the power of negative n gives 1 over a to the power of n. Here in this case, n represents negative 3 and negative 4. So, negative power can always be written as a fraction. Now, speaking about the negative indices, I have given you two examples. The first one is 7 to the power of negative 3. Now, when you see a negative indices, you should keep in mind that it can be written as a fraction. Now, what is 7 to the power of 3? 7 to the power of 3 is 343. That is 7 multiplied by 7 multiplied by 7. Now here in this case our power is negative. That means it has to be a fraction. So 7 to the power of negative 3 gives us 1 over 343. Now the second example I have given to you is 9m to the power of negative 4. Now 9m to the power of negative 4 refers to m. The power of m is negative. So what can be written as a fraction? The m has to be written as a fraction. That is 9 multiplied by 1 over m to the power of 4. That is as per the rule a to the power of negative n gives 1 over a to the power of n. So in this case our negative n is negative 4. So it has been written as 1 over m to the power of 4. And since the power of 9 is not negative, it is positive, it still remains the same. Now I speak about the fifth law, or the power of 0. Now you should understand that any term to the power of 0 is equal to 1. You know that any number divided by itself is equal to 1. Likewise, for instance, 8 to the power of 0 is 1 or 2 to the power of 0 is 1. So any term to the power of 0 gives you 1. So if you get a term with a power 0, your answer will be equal to 1. Now I have given you two examples of negative indices. The first one I have given as x to the power of negative 5. Now here our power is negative. So when you see a negative power, you should remember the rule I stated before. That is, negative powers can be written as a fraction. So the negative sign in front of the power sends it to the bottom. That means x to the power of negative 5 gives us 1 over x to the power of 5. Now in a second example here which I have given is 1 over x to the power of negative 2. Here the negative sign is in front of the power and it is already on the bottom of the fraction. So what happens? So just send it to the top. That is 1 over x to the power of negative 2 turns out to be x to the power of 2. Since it is already on the bottom of the fraction, it goes to the top of the top. Now I'll introduce to you fractional powers. You know fractions. Fraction always has a numerator part and a denominator part. Likewise, for fractional powers, you have a numerator and a denominator. And both the numerator and denominator of a fractional power have meaning. Now what does the top line of the fractional power or the numerator part represent? The top line of the fractional power gives the power of the whole term. What about the bottom of the fraction? The bottom of the fraction stands for the type of the root. Now I have stated for you the two rules of the fractional powers. The first one is the nth root of a gives us a to the power of 1 over n. Now for the second one, that is a to the power of m over n means the nth root of a raised to the power of m. So these are the two rules for the fractional powers. I will illustrate you with the examples in my next slide. Now again, I have given to you some examples of fractional powers. Now, I told you previously, for fractional powers, the bottom of the fractional power gives us the type of the root. And here in this case, square root of 4 gives us 4 to the power of 1 over 2. So, the bottom of the fractional power is 2, which gives us the type of root. So, type of root is square root. And the top of the fractional power gives us the power of the whole term. Now, the second example given is cube root of x gives us x to the power of 1 over 3. Again, as I stated previously, the bottom of the fractional power gives us the type of the root. So, the bottom of the fractional power is 3, which represents cube root of x. And the top of the fractional power gives us the power of the whole term. And here the top of the fractional power is 1. So, the power of the whole term is 1. So, we can write cube root of x as x to the power of 1 over 3. Now, nth root of a, the whole to the power of n. We will simplify this with an example, this rule with an example. 8 to the power of 2 over 3. 8 to the power of 2 over 3 gives you cube root of 8, the whole to the power of 2. Here again I stated previously, the bottom of the fractional power gives you the type of root. Then here the bottom is 3. Of the bottom of the fractional power is 3, so it is cube root of 8. And the top line of the fractional power gives us the power of the whole term. The top line of the fractional power is 2, so it will be cube root of 8, the whole to the power of 2. So here you will have to first simplify the bracket portion, that is the cube root of 8 is 2. So 2 squared is going to be 4. Now this is as per the rule, nth root of a gives us 8 to the power of 1 over m, and nth root of a raised to the power of m is 8 to the power of m over n. Now again I have given for you one more example, that is 27 to the power of 2 over 3. Now here you can see the fractional power is 2 over 3 and the bottom of the fractional power is 3. That represents the type of root. That means it has to be cube root of 27. And the numerator of the fractional power is 2. That represents the power of the whole term. So you can rewrite 27 to the power of 2 over 3 as cube root of 27, the whole to the power of 2. Now what is cube root of 27? First you have to solve or simplify what is in the bracket. So cube root of 27 is 3. Now 3 to the power of 2 is 9. So your answer is 9. So I repeat, if for fractional powers, the bottom of the fractional power represents the type of root and the top line of the fractional power gives the power of the whole term. The power of the whole term 3 is 2. So 3 squared gives you 9.